So, hello everyone. This is Kai, and today I will explain you very basic information about index. So, this is a video where I can explain you about how this index works. So, let's think about the very basic example. So, when you have, let's say, it's 2 times 2, you will get a result of 4, right? You can also say that it's 4 is equivalent to 2 squared. So in other words, uh, the indexes are adding up, right? Before that, I want to talk about a certain terminology. So in terms of calculations, we got called base form, which is 2, and we have an index, which is 1. So when you multiply 2 times 1 times 2 times 1, the base form stay the same. The rule is the index added together. As a result, you got 2. So that is when it is multiplied. And the second context is when you know that 1, 2 is divided by 2, you will get 1. Or 4 is divided by 2, you get 2. When you get 8 is divided by 2, you get 4, right? So let's look at the first example for the scenario 2. So 2 divided by 2 is 1, and everyone knows. So, but then 1 is essentially 2 to the power of 0. So the exception is whatever the base is, if the index is 0, you get a result of 1. Okay, so let's think about the second one. So here we learn that 4 is 2 squared, and we know that if it is just 2, we know that index is 1, right? So 2, so you got 2, but that also means that is if you just subtract the index, you get the same result. So just 2 to the power of 1, which is just 2, right? The same go for this. 2 to the power of 3 divided by 2 to the power of 1 equal to 2 to the power of 3 minus 1, which will give you 2 to the power of 2, which will give you 4, right? So this is the second example or the second scenario. Of course, let's go to the third scenario, which is, I want to refer back to this one. Any base, if the index is equal to 0, you will get 1. For example, 5 to the power of 0 is 1. 6 to the power of 0 is 1. 7 to the power of 0 is 1 as well. All right. So let's go back to a little bit of harder part, which is called complex problem. So in the complex problem sets, I can give you a little bit of run through of how I'm going to solve those ones. Okay, let me check. Like this. For example, a um, um, a5 divided by a of 1. So we know that it's a5. We use the bar sign to represent division divided by a over 1. So as a rule 2 says, if the the same base, different index, and if they are in a division form, you can say the index is subtracted. So in this scenario, base is A, the power of the index is 5 minus 1, and as a result, you will be left with A to the power of 4. All right, let's go to this. What if is A to the power of minus 1, right? We never thought about that. So if you want to make sure the index is positive instead of negative, you flip the sign. So 1 over A. So for example, another thing you could think about is 2 to the power of negative 2, right? So you can say 1 to the power of 2 squared. So that means you flip the sign. Now your index is positive. For example, the question states to simplify this, you will get 1 over 4. All right. Let's think about something hard. What if I have this 3x half times 4x half? So we know that if you multiply everything, you multiply numerical, and you also multiply the base form in different separate way, but still they multiply to each other, right? So you can also think like 3 times 4 because they are numerical. But in terms of base, you can think like because it's the same base, different index, and they are multiplied to each other, we need to add them together, right? So 3 times 4 is 12. And if you add together, half, when you add together, it will give you 1, right? So if you further simplify, 12x, that's it. So this is the end of the video, and I hope that you sort of understand everything I went through. Thank you so much.